Thank you very much, Brian. Good afternoon or good evening, everybody. My name is Matt Wood. I'm the General Manager of Data Science here at Amazon Web Services, and that rather bizarre title basically means that I get to talk to smart people such as yourselves about how to build sophisticated, scalable applications that enable your business and enable you to do wonderful things with your data. This always gets left to the end, so I just wanted to thank you very much for taking the time to listen and join our webinar today. You could have been anywhere in the world today, so we really appreciate you taking the time to listen to a little bit about the work we've been doing around DynamoDB and some of the work that our customers have been doing in enabling their mobile applications using DynamoDB for a backend. So I really just wanted to talk about three things today. It's a presentation in 3 acts. I'm going to start off with just a quick introduction to DynamoDB. Then I'll talk a little bit about how customers are using DynamoDB today to power their mobile applications. And then finally, we'll round out with some next steps, some free stuff, and some tips on getting started. So let's move into Act 1. Where we're going to talk a little bit about DynamoDB, what it is, and take a quick look under the covers of DynamoDB about how you can build schemaless applications which can deliver information to and from your mobile device at very high throughput and can store that data at basically unlimited scale. So for those of you who may be familiar, Amazon Web Services basically provides a collection of foundational building blocks on which you can build these sophisticated, scalable applications. We have everything built on top of a global infrastructure. On top of that, we layer in networking. And then we have main areas of services such as compute, storage, and databases, which allow you to dial up the resources that your application needs as and when you need to, and then pay for them with utility-style billing. So that means you only pay for what you use, and you can use as much or as little as you like. In addition to that, we have a collection of application services which let you lash all these different individual building blocks together. And then we have deployment and administration tools on top of that as well. So today I'm really going to concentrate on our database services. And we have 4 main services available today. A relational database service, Amazon RDS, Redshift, a data warehousing service, and Elasticache, which is a caching service built on top of Memcache and Redis. But I'm going to talk primarily today about Amazon DynamoDB. Now, Dynamo was actually a design pattern which was created inside Amazon.com many, many years ago. And you can actually look up the original paper published by the Amazon CTO, Werner Vogels, up on the internet. There's a white paper available about how we started to see traditional relational database management systems as something of a Swiss Army knife. We were trying to do a lot of things with them. We were trying to do analytics reporting. We were trying to do scale with them. We were trying to build all sorts of bells and whistles on top of the traditional relational database. But this Swiss Army knife approach actually wasn't the best fit. And we started to take the approach of what if we started to build a database service and build a database system where it was built for a distributed system, where availability and scale were foundational building blocks. They were the founding principles of Dynamo. And we wrote that up as a paper. And then many years ago, as we were developing that technology inside Amazon, and this was used to power the Amazon website and the checkout system and all the rest of it, we used a lot of that operational experience to start to build out a new generation of service, which we launched about 18 months ago, called DynamoDB. So this isn't the original Dynamo system which has just been exposed. This is something where we've taken a lot of our operational learning and then built a new system from the ground up to build large internet-scale web and mobile applications. So at its heart, Amazon DynamoDB is simply a simple key value store. If you're a developer, you can think of it as a large distributed array or hash of keys and values. But when you start to dig into it a little bit, what it actually provides is predictable performance. It's designed for massive scale. It can store an unlimited amount of data under its hood. It's fully managed, which means you don't have to take on board any of the laborious database administration tasks, which are so common with relational systems or running NoSQL style systems on EC2. And it's designed to be delivered at extremely low cost. And since this is a presentation in 3 parts, DynamoDB really has 3 main areas, 3 main collections of benefits. One built around benefits for developers, one built around benefits for operations folks and system administrators, and a group which is built around benefits of the users. So by using DynamoDB, you get access to developer tools, operation support, and a great service to power your mobile applications with low latency. So let's dive into some of these in a bit more detail. So first and foremost, Amazon DynamoDB is a great environment for fast application development. Using this key value store, which doesn't require a schema, allows you to build your applications much more quickly. You can start to work with flexible data models. DynamoDB has an amazingly simple API. It's one of my favorite APIs that we offer here at Amazon Web Services because it fits on just one slide. It's built and designed to handle very high-scale queries and very high-scale reads and writes. And it also has offline or laptop-style development environments so you can code and develop without being connected to the internet. So let's take a look at these in a bit more detail. Two customers which use DynamoDB today in production that talk to the fast development environment are Shazam and Earth Networks. So Shazam built a new Super Bowl promotion at the Super Bowl most recently, which resulted in millions of interactions over an extremely short period of time. So Shazam, if you're not familiar with it, is a music detection or tagging service where you can hold your mobile phone up to the TV or up in a restaurant where music is playing. Shazam will listen out to the music which is playing and then tell you the artist and provide links to purchase it and those sort of things. As part of the Super Bowl promotion, they actually embedded links inside all of the Super Bowl adverts and then encouraged customers to hold their phones up to the Super Bowl adverts, some would argue the most successful and popular part of the Super Bowl, hold their phones up and detect various different tagged media as part of the adverts. So this obviously only runs over the short advert breaks throughout the Super Bowl, but they expected millions and millions of interactions over this short period of time. They built all of this application in just 3 days, from design all the way through to a production-ready application, which launched alongside the Super Bowl. This talks about not only the fast application development environment that DynamoDB provides, but also the scale that you can achieve without any real upfront commitment in terms of going off and buying hardware or the operational skills to build that sort of environment to power those sort of engaging mobile and second screen environments. The second is Earth Networks, who build the popular WeatherBug mobile application. They've been using lightning detection and alerting for about 40 million users each and every month. And they developed and tested this in just weeks using DynamoDB. A nice point on the low-cost environment as well is that they were able to do this at 1/20th of the cost of a traditional database approach. So not only does DynamoDB allow you to build applications more quickly, but you're not sacrificing anything in terms of cost or in terms of performance in doing so. So two nice examples, two nice use cases there of mobile apps being built on top of DynamoDB. But what makes this fast application development environment so speedy? There's really, again, three things. The first is relationship modeling. The second is that simple API that I talked about. And the third is the ability to create very high-scale query patterns against arbitrarily complex data sets. So let's dive into these in a little bit more detail. So if you're not familiar with DynamoDB, a table in DynamoDB is really just a collection of items. And an item in DynamoDB is just a collection of attributes where each attribute has a key and a value. So this really is a table which is just a big bag of keys and values. There's no real structure around this data other than the keys and the values that you place on it. So there's no formal schema, which means you don't have to migrate that schema, and you're not beholden to that schema as your application needs change. There's only a couple of decisions that you have to make when you start working with DynamoDB. You obviously don't have to decide on a schema because you can bend and flex that depending on your application needs. One thing that you do have to decide up front is your primary keys. So by DynamoDB, you can use two different types of primary key. The first is a hash key. This is very much similar or equivalent to a unique ID inside a relational database. But you can also use composite keys. This is a collection of a hash key and what we call a range key. And an example of a good hash key might be, let's say you're running an e-commerce site. So a good hash key might be a customer ID, where you're recording a collection of orders against that customer. A composite key, a good example of that might be a customer key linked with a date or time, which would allow you to retrieve all of the orders for a particular customer within a range. So you can use composite keys alongside hash keys to build more complex queries for your application. Primarily, items are indexed by primary key. There are also local secondary indices available on DynamoDB, which I'll talk about in a minute. And data is automatically partitioned by DynamoDB, primarily based on the hash key that you provide. So DynamoDB, although all you have to do is add and read and write data into the service, under the hood, DynamoDB is partitioning that data out across multiple servers to provide very high availability and to be able to automatically scale to respond to the amount of throughput that your application needs. So choosing those hash keys and those composite keys is a key important step, no pun intended. Using this very flexible schemaless key value approach, you can do things that you're probably used to doing with a relational database system, such as modeling one-to-one relationships. So a good example of this might be using a table with just a simple hash key. So where you might have, in this example, a users table and a games table where you want to model a one-to-one relationship between the user and the games that user has played. So you can see we have a users table where the hash key is just a user ID, and we have a selection of attributes alongside those. So these, again, are the keys and the values. So the email being bob@gmail.com and the date that they joined the service being the two attributes available for that first item. We also have a thread that has, you can see, a disparate set of keys and values. So we've added a gender or sex in there, and thread is male. We also have a games table here where we have a game ID as the hash key, and we have the attributes in there as well. So you can see we can have join date and the launch date and the hash key all joined together to form these one-to-one relationships using just the hash key. You can also model more complex relationships, such as one-to-many relationships. So here we would use a table which has a hash and a range key associated with it. So an example here where using a mobile game, for example, is that one user can play many games. So you'd end up with a user games table where you have a hash key of the user ID, in this case Bob, Fred, and then Bob again, you can see at the bottom there, and a range key which is the game ID. So this is the name of the game that they were playing. And we can use these along with our one-to-one relationships to build out complex queries and again store arbitrary amounts of information against each of the user game table items. So we have high scores in there where those high scores were what date those were made on and when they were last played. So this allows you to create these rich query patterns and store arbitrarily complex data in this key value environment. So let's take a quick look at DynamoDB's simple API. This is the entirety of the DynamoDB API. It's here all in one side. You can see it breaks down roughly into 4 different areas. We have a collection of API calls to manage the tables of DynamoDB. So create table, update table, delete table, describe table, and list tables, which do pretty much what you would expect them. We have a list of API calls to read and write items over on the right-hand side, so put and get items, and also update and delete items. We also have bulk convenience methods for batch get and batch writing items. And we have query-specific items and scan items as well. So the query is the main port of call you're going to use to query the data in your database. Scan allows you to do a full table scan. And that's the only API call which isn't guaranteed to deliver a consistent, predictable level of performance because it has to go through every item in the table. So let's take a quick look at the query-specific items. API call. So the query API call allows you to basically take a look at your data and slice and dice it based on the hash and the range primary keys on your tables. You can retrieve all the items by a hash key, so you could get all of the high scores that Bob has scored, for example. But you can also apply range key conditions. So you can do equality, greater than, less than, greater than or equals to, and so on and so on. You can also do begins with and between for more advanced queries. DynamoDB can sort your results. You can work with counts, and you can retrieve the top and the bottom end values. And you should expect paged responses for very large queries where each page is limited to 1 megabyte in size for each API call. And you can then call the next page with a token that DynamoDB will give you. so you'll know when you're being paged. So these query patterns allow you to build very complex, very supportive queries for your mobile applications. DynamoDB also supports local secondary indices. So in this case, these are designed for high-scale multi-tenant applications where you have multiple users stored within, data from multiple users stored within a single table. So you can index local to the hash key, which basically means that the local here replies to a partition within DynamoDB. And you can add 5 of these indices without any performance degradation on each and every table. So looking at our example here at the bottom, you can see we've got our user games table again, where we have our hash key as a user ID. We have our range key as a game ID and a collection of key value attributes. We can then take, if we wanted to query just based on the time that a game was last played, we can create a local secondary index based on that, where we have now a hash key, which is the user ID, and the range key now becomes the date of when that game was last played. This allows us to do faster lookups and index against those keys and those values based in that attribute in the user games table. You can see that we also have a column called projected attributes. This allows you to elevate attributes from a user games table into the index for faster lookups. So moving on. We have another new announcement coming up, which we announced recently, which is the availability of DynamoDB Local. DynamoDB Local is a disconnected development environment for you to develop against. So it has full API support against the API that I just showed you on DynamoDB, but it's available as a binary which you can download and just run locally on your local laptop. So this means that you can develop your applications against the Dynamo API either without a network connection or have it behave as if it would when you deploy your application against EC2. This is a very useful tool for building and for testing your applications, because this can be used for mocking out a live DynamoDB table running up on AWS with a local test tool. More information is available about that on our website, and you can download it today at aws.amazon.com/DynamoDB. So let's take a look at the operational benefits of running on DynamoDB. I guess the biggest thing to say here is that DynamoDB is designed to be essentially admin-free at any scale. So that means that you can build very, very high-scale applications such as Shazam and the WeatherBug team did without having the operational skills of managing very, very large database systems that can handle hundreds of thousands of IOPS each and every second. So again, some good examples of where this has been used by customers. We have a good quote here from SmugMug, which is a photo sharing site. And they say that even though they have years of experience with large, complex, NoSQL style architectures, they were happy to be finally out of the business of managing it all themselves. And this really talks to the point that when you start to remove some of this undifferentiated heavy lifting associated with managing databases at scale, you get to reinvest that time and that money and that expertise back into your application rather than wasting it on the muck of just provisioning servers and partitioning data, which DynamoDB will do for you automatically. Another good example from Sumo Logic, an analytics company, they say that our previous NoSQL database required almost a full-time administrator to run, but now AWS takes care of all of it. And so even if you are running on other NoSQL databases, it's much more efficient to run in this admin-free environment up on AWS. So again, 2 more good use cases there that we've seen be very useful. And when we talk about admin-free, these are some of the things that we're talking about. We're talking about removing the need to have to go off and provision and more importantly, configure servers and storage, which can be very challenging when you start getting up to scale and can be very time-consuming even at low scale when you're running development and test servers. You have to monitor and handle hardware failures. DynamoDB does all of that on your behalf automatically and actually will replicate data across multiple what we call availability zones. So these are one or more data centers which have redundant connectivity and are redundantly powered and on separate fault lines and floodplains and all the rest of it. So when you're using DynamoDB, you're actually getting asynchronous replication across multiple data centers, across multiple availability zones. And we won't acknowledge that a write to DynamoDB has taken place until that data is stored across multiple data centers. Then you have to go through the updates of hardware and software. You have to manage cross-availability zone replication, which DynamoDB does for you. And then you have to repartition data and balance clusters as your requirements and scale needs change. That can be challenging to do going up. It's also very challenging to do when you need to scale down. And being able to do that at short notice to scale down during short periods or quiet periods of your application time, either in the evening or when you're not working on Super Bowl ads, then there's some nice cost savings available there as well. So DynamoDB introduces the concept of provisioned throughput. So irrespective of the amount of data stored under the hood and how DynamoDB is managing that, DynamoDB provides consistent, predictable connectivity, so single-digit millisecond latencies when running against EC2. It does this through this provisioned throughput request-based capacity provisioning model. So throughput is declared and updated via the API. And so when you create your table or when you update your table, you tell DynamoDB how many reads per second and how many writes per second your application is going to need. And DynamoDB will go off and provision the amount of throughput for the amount of data that your application needs on the back end. So it'll manage the databases for you. DynamoDB basically handles all of the information and all the operational performance under the hood. So it will reserve the capacity and make it available when it's needed. It'll provide you with scaling up triggers when repartitioning and reallocating. And it'll do all of this scaling up and scaling down and repartitioning without impacting the performance or availability of your application. So as you change the API throughput rate on your database table, DynamoDB will execute on that and reprovision the hardware and repartition the data automatically, but you won't see any downtime or any impact to the throughput of your application. So DynamoDB makes all of that available with just a single API call, which would once have been extremely complex and extremely time-consuming to set up and may have involved downtime for your application, which with a mobile application is not what you are aiming for, obviously. So the third area is where DynamoDB is useful to users, and that really is in creating this durable, low-latency environment that your application requires. So as we talked about already, DynamoDB will replicate the data under the hood across these availability zones. So once you write your data in, it will continuously replicate against multiple availability zones, and you'll only get an acknowledgement of a write when it's written across multiple data centers. So as soon as it's persisted to disk, and we use custom SSDs under the hood to provide this low latency single-digit millisecond performance, that'll get persisted across multiple SSDs in multiple data centers across multiple availability zones, all automatically. All you have to do is make one API call. Reads are very easy as well. We support both strongly and eventually consistent reads from databases, and you can make a decision of what database reads you make at what time, and there's no latency trade-off for making either strong or eventually consistent reads from your database. So an example of this can be seen with this latency graph here, where we have server-side latency across all of the APIs. So you can see here that if we zoom in on this area, you can see that the average for this particular application running on DynamoDB, the average response from the APIs was less than 3 milliseconds, and the TP90 was less than 4.5 milliseconds. This is a very, very consistent, very predictable environment for the application to read and write data from, and that makes it a very good experience for your customers when they're working on mobile applications where latency is very important. So, speaking of mobile applications, let's move on to Act 2, where we're going to talk a little bit about just two use cases of where DynamoDB can be used alongside and to support a mobile application. So one of those is in building location-aware applications. So DynamoDB, because of its scale and because of its key value schemaless structure, is particularly well suited for building geospatial queries. And so a couple of months ago, we actually announced a new library, a new code library, which provides a small domain-specific language for building location-aware apps on top of DynamoDB. And this allows very, very easy geospatial queries using DynamoDB as a backend. So we call this the Geo library for DynamoDB. It's available as a Java jar file, so you can just drop it straight into your existing development environment. It allows you to create geospatial data items against a DynamoDB table either up on AWS or running as a test and development environment or using DynamoDB local, by providing latitude and longitude, and also attribute pairs maintained by the application. So that's where you put the metadata associated to your check-ins or your reviews or whatever it happens to be that are tagged to a particular location on the Earth. So the library takes care of creating and maintaining the hash keys, all the range keys, and the indexes that allow for fast and efficient execution of location-based queries. So all of that creation of the tables, all of that creation of the keys and the values and the range keys and building the queries for those range keys are handled by this geolocation library on top of DynamoDB. So this really gives you the best of both worlds. It gives you the predictable, consistent performance of DynamoDB. It gives you the ability to be able to scale to store an unlimited amount of data under the hood, but also gives you a very, very easy to use API, which is domain specific against geographic information. So there's a little bit of code here that hopefully you can take a look at. This is all you need to do in Java in order to be able to create a new geotable. You can see all we do on the first line there is create a new database client. We tell it which region of the Amazon Web Services cloud to run in. Then we go off, create the configuration, and go off and create the new table. You can see here we're not having to specify any primary keys or hash keys or range keys or anything like that. The data manager is going to do all of that for us through this library. It's very, very easy to get up and running. Once you've got that table, it's specifically built to store and retrieve what we call geopoints. So these are points which are tagged against a geographic location. So this allows you to create those points of interest for reviews or where the photos were taken or where the check-ins take place. You can store a latitude and longitude, which your mobile device will conveniently give you through the local device API. You can just write those points back to DynamoDB using the putPoint method inside the library. So it really is as simple as getting the latitude and longitude from the mobile device, the GPS on the mobile device, setting the attributes, the keys and the values, and then pushing those back through the library back to DynamoDB. And all of that happens, of course, with this consistent, predictable performance. Once you've got your data in there, you can start to query against that. So you might want to do a query rectangle. This is very useful if you're viewing a square or rectangle-shaped map on your mobile device or your tablet. This allows you to locate all the points that fall within a pair of two other geographic points. So as your users are flicking and tweezing apart their maps on their touch devices, you basically take the two latitude and longitude coordinates of that and then define the rectangles and project them back onto your map. This is how you would query that data which is stored as geographic latitude and longitude back in DynamoDB. Again, very, very easy. Just get the coordinates from your device and then ask DynamoDB for the results to come back. And they'll be paged if there's a lot of information to come back and a lot of points of interest which the user is requesting. Similarly, you can also use a query radius method, which gives you all of the points of interest which are local and close to a given radius of where the user currently is. So let's say instead of just looking at a point on the map, you want to tell them all of the points of interest which are close by, then the query radius will do that for you again. Again, all you have to do is create the center point, which could be the current location of the user, and then send off that request, and you'll get all the results back from DynamoDB. So what's happening behind the scenes on this? Well, it's relatively straightforward. Although all you're doing is calling a couple of API calls, DynamoDB and the library are doing all the heavy lifting for you. So the first thing is that DynamoDB on the back end is creating a virtual grid that overlays basically the entire planet. And each grid cell has an address that is derived from its location of the cell. So when those geopoints are inserted into DynamoDB, a geohash is computed and used to map the data record to the correct grid cell. So then all you have to do is store that item's geohash as an image attribute, and you can use local secondary indices to recall that attribute based on the rectangle or the radius that you want to recall the points of interest. So the library then post-processes the results of those items and returns only those that are within the specified bounding box or radius. So all of that is happening under the hood. All you have to do is make a couple of API calls. And just to show how simple it is, we have some iOS sample code available. You can see it here available. It's called the Find Yourself example application. And all the documentation, library, and sample source code are available via GitHub. You can get it at github.com/AWS/DynamoDB-geo. So all of that is available to show you how to implement this using a library, using a backend running on DynamoDB. So location-aware applications are obviously extremely common. Another very common use case that we see from customers is using push notifications with their mobile device. So these are typically high scale, and they can either be personalized notifications for your applications, which you target to specific individual users, or you might want to send large-scale notifications to large groups of users on their mobile devices. So let's quickly back up and take a look at notifications in general and how they're currently implemented. So today, mobile push notifications are used to basically engage customers when your app is not currently active. And I'm sure anybody running a modern mobile application has seen these pop up on their device or on their lock screen. The users typically have to opt in to receive them. It's mandated by the device operating system. They're delivered to a specific app on a specific devices, and they're typically short messages. Customers can choose to read, ignore, or acknowledge the notification, which typically launches the app. So you can see some examples here where the Seahawks have won, and we've got a gate change notification for our upcoming flight. So I'm sure most of you are familiar with those. Here's how they're typically implemented on the back end. What typically happens is that you have your application running up on the cloud, and you want to be able to push this up onto a specific mobile device or group of mobile devices. Okay. Thank you. So you typically want to be able to push that up onto your mobile application. In order to be able to do this, you typically use some sort of platform service, either provided by the operating system or provided by some other third party. In order to do that, you have to do all sorts of, again, undifferentiated heavy lifting associated with managing the permissions to talk to those devices. So the platform service typically manages token feedback from the application, and the devices themselves will send token registration information to be able to manage whether the permissions of the notifications. So developers that want to take advantage of push notifications have to be able to manage all of this for each device and must proactively swap or disable them based on feedback from the customers. So all of this, when you're just trying to build an engaging environment for your application and for your customers, is, again, what we call undifferentiated heavy lifting. This is time that would be better spent focusing on what information to push to those customers, what features you want to enable within your application that rely on this method of notification, rather than on the complex implementation of that feature, of those notifications. But it gets even worse than that, because each platform-specific push service works slightly differently. They have different APIs, they have different features, and they have different feedback mechanisms for managing those tokens. So what you actually end up with is something more similar to this diagram, where you have a single application that has to have multiple implementations of similar but different APIs that talk to similar but different notifications on similar but different applications running across many, many devices. So push notifications get very, very complex as you scale to support millions of devices, and you need to be able to support those across multiple different platforms. The approach we use at Amazon Web Services through a service we have called the Simple Notification Service, or SNS, is to use a push intermediary service in order to be able to talk to and mask all of this complexity. This basically allows you to abstract all the complexity of managing all of the different APIs, of managing all the different devices, and just lets you focus back in on what your application should be doing, which is adding value to your own customers. So developers use these intermediaries to abstract platform-specific APIs and manage tokens for millions and millions of apps. So you get to maintain that engagement with users on basically any platform and manage tokens to ensure messages are delivered reliably, but you remove the operational complexity and the scalability required to implement all of this. And you can do all of this, obviously, at much, much lower cost, even though the platform services themselves are free. So probably about 2 months ago now, we announced an update to the Simple Notification Service, which enabled it to be used as a mobile push service. So Amazon SNS now supports mobile push, and in a similar way to DynamoDB, which abstracts a lot of the complexity of dealing with the data stored across many servers, so SNS abstracts all the complexity of dealing with multiple notifications across multiple platforms and millions of devices. So you can use this as a cross-platform push intermediary service to support iOS devices, Android devices, and of course, Amazon Kindle Fire devices. And what we've seen customers do, and a popular pattern, is that they'll use SNS for the distribution mechanism of the notifications, but they will use DynamoDB to store the IDs and to store the metadata associated with either the customer or the devices to which they're going to push their mobile notifications. And this allows you to build very, very complex patterns of delivery of push notifications. For example, you can send distinct payloads to each platform. So you could send a distinct payload to all of your customers running on iOS. You could send a different notification to everything running on Android in accordance to the various different platform norms. But you can also do publish once and deliver everywhere. So you can do a single publish and deliver to all of your devices across all of the different platforms. And you can manage that through SNS and store all the information on the back end using DynamoDB, which is again perfectly set up to handle millions of queries and handle millions of devices and handle the scale underneath that. You can publish unique messages to either individual devices, or you can broadcast identical messages such as adverts or new features or a new version of your application to many devices at once. So we call this direct publishing, where you publish a notification to a single server, or you can broadcast using SNS topics a single message to multiple devices. The good news is that SNS consumes all the feedback from each of the platform and manages swapping and disabling the tokens on your behalf. So again, all of that heavy lifting is managed for you using the service in delivering the notifications, and all the heavy lifting in managing the data about the mobile devices is managed by DynamoDB. So you can write to one stable endpoint per device, and you can also access the feedback, but you don't have to if you don't want to. So the good news is that SNS offers easy scalability. So you can just start by sending a couple more messages when you get up and running, but you can go from a few messages as your application launches to hundreds of millions without managing the scale of distribution. And you can go from a few devices when you launch to hopefully hundreds of millions of those devices, again, without handling the complexity and scale. SNS is going to abstract all of that away from you, and DynamoDB is going to abstract the headaches of managing the infrastructure on the database side. So you can do all of this without provisioning, configuring, or managing a single server with either data storage or notification delivery. And so those are two of the common use cases that we see with mobile applications using DynamoDB, building these very, very scalable, very, very viral applications which increase user engagement using notifications and that build out novel, inventive new features using geolocation. So in the third short final act, we'll talk about some next steps and how you can use some of these services for free. So to get up and running, all you really have to do is download some of our SDKs. So we have SDKs available for a very wide variety of programming languages, from Java, iOS, Android. We have SDKs for Node.js for building nice scalable backends, .NET, PHP, Python, and of course Ruby and Rails. And we've also integrated a number of these into existing IDEs. So whether you're using Eclipse or Virtual Studio, or you're more comfortable on the command line, either on Linux or PowerShell on Windows, you can get these command line tools and SDKs available, which you can just plug in and start using these things straight away. So, for example, the Python and Ruby SDKs will handle all of the registration and security for DynamoDB by managing the tokens that it uses for authentication for you. So there's some nice advantages to working with these SDKs. To get up and running, we also have a free tier. You can learn more about this at aws.amazon.com/free. And this includes a free tier for DynamoDB, where you can receive free DynamoDB tables, up to 100 megabytes of storage, and you can provision 10 units of read capacity and 5 units of write capacity for free for new customers for a year. So if you want to learn more about this, go to aws.amazon.com/free and learn more about DynamoDB. Likewise, the SNS Mobile Push will provide 1 million free per month. So that's 1 million publishes and 1 million mobile push notifications for free. And after that, it's just $1 per million notifications. You can see the other prices there. So this is a very, very free way and then a very cost-effective way of delivering these sort of new features at scale. And you can set all of this up for SNS Mobile Push using the console. So there's one very simple workflow to create apps on any platform, and then you can upload or paste in exactly the credential you receive from each platform when you sign up to register to deliver those notifications. And there's easy migration of existing applications by batch uploading existing tokens if you're migrating from an alternative platform for managing this. So it's very, very easy to get up and running, very, very easy to migrate onto when you're working in this environment. So just to summarize, we covered three things. We gave an introduction to DynamoDB, including the schemaless tables and a little bit of information about how you can construct one-to-one and one-to-many applications and use so-called local secondary indices. We talked about using DynamoDB with a mobile application for both geospatial applications and using SNS Mobile Push notifications. And we also talked about the next steps, how you can get up and running with free stuff, and how you can get started either in the console or with the SDKs. With that, I'd like to thank you very much for your attention. That brings to close the presentation component of this webinar. I've been joined while we were talking by representatives of both the DynamoDB and the mobile push SNS team. And so if you have any questions relating to this area, we would love to answer them for you now.
You'll hear a few seconds of silence on the line while we reorganize our chairs for the Q&A portion.
Go ahead, do you want to do that one?
Yeah. Sure. So here's a question. Do you need to store the AWS secret keys on the device, and is that a security risk?
So this is in regards to mobile push notifications in particular. If I have my token on the device and it needs to get registered with SNS, ultimately there needs to be some sort of authentication. The easy but not recommended practice is to embed some narrow credentials on the device itself. This is easier to build, but as the person asking the question suggests, that's not an excellent security practice. The preferred security practice is to use one of two options. The first is an AWS provided option called the token vending machine that creates temporary credentials that allow your device to perform this particular action of registering itself with SNS in a way that is secure because the token expires after it's used for that initial purpose. And so the first option is the token vending machine. The second option that some other customers use is a proxy, where actually my app doesn't speak directly to SNS at all, but rather speaks to a cloud service whose job it is to accept input from the app. And the cloud service then interacts with SNS. And so there are, to sum up, three options. One is the simple but not recommended way that is typically used for development and testing, which is to embed narrow credentials directly into your app. That's not the recommended way. The two recommended ways are to use the token vending machine or to use an intermediate proxy.
Okay, thanks, John. So we have a question about DynamoDB. Does DynamoDB support disaster recovery in case region 1 data center went down? And can I retrieve the data from a backup data center transparently? So the short answer is yes. When we talk about a region, though, a region is a group of availability zones, and an availability zone is a cluster of data centers. So if a data center went down, that doesn't mean a region or even an AZ is impacted. DynamoDB is architected to span multiple availability zones continuously, so the data is constantly maintained in multiple locations at once. So to be sure, we recommend high availability work and be built and architected within a single region, as does Amazon.com, for instance. For DR, though, yes, moving data out of the region is a good idea. So we've recently announced, if you look at Jeff Barr's blog, a data pipeline template that enables you to move data from a DynamoDB table in one region and move it to basically load another table in another region, and to do that with basically push-button automation. So yes, the answer is yes.
We have a question on auto-scaling. So do you have any plans to provide auto-scaling for DynamoDB? The answer is that you can actually do that today. So when you set up a new DynamoDB table, DynamoDB will ask you if you want to set up notifications when you start to reach the limits of your provision throughput. So you can actually tell DynamoDB when you get to, say, 80 or 90% of your provision throughput that you've set up. It will send you either email notification or a programmatic notification, again using SNS, and you can respond to that in a programmatic way. And so there's some code available up on our website and up on the developer blog, which will give you the guidance on how you can respond to those notifications. All you do is just make an API call to decide what to do by adding or removing capacity as you start to move in and out of the limits of your operational limits of your provision throughput. So you can actually do that today.
Great. Thanks, Matt. So we have another question. Is DynamoDB local only for development purposes, or is it likely to be deployed as a production option as a replicated source? Definitely the first, the former. It's a development environment designed really to give you disconnected access to the API. So the APIs are essentially simulated. It allows you to do laptop development wherever you are. But yes, for any degree of scalability, the service it's not the service. It's an emulator of the API. So no, it is not designed for scale, and it's definitely for development purposes.
Wrap it up.
Oh no, we've got a few more here. So just one comment. Also, we've had a few questions about what are our plans. We don't share those plans publicly in this sort of forum. But everything you ask is great, and other customers feel the same way, and they ask us, and we are driven by customer requests. So these are well taken and things that we do embed into our roadmap as we go forward. So you can be sure that if it's not here today, then we're certainly listening and planning something coming up. So that covers things like cross-region replication, online secondary index creation, and so on, which we've had a few questions about. We've also heard a question about the difference between DynamoDB and SimpleDB and when you would recommend one versus the other. There is actually a decent discussion on that on the website. We recommend you go there to the DynamoDB website where you can check on the differences between them. Essentially, with local secondary indexes, most of the use cases that you would deploy for SimpleDB are available in DynamoDB. SimpleDB indexes every attribute, so that's a constraining factor in its ability to scale. So that's the only thing there. SimpleDB is extremely versatile, but it is designed for lower scale, smaller data sets. DynamoDB has no such limit, and for most use cases is generally significantly cheaper as well. Is there any limitation of query data from DynamoDB per second? Can I query 50 million data, I presume that means data items, from DynamoDB in 1 second? The short answer is yes. It all depends how much throughput you give that sort of request and how well structured your data is. So DynamoDB is a distributed system that uses the hash key to distribute data across the data set, the partitions. So if you're doing sort of a batch get of, say, 100 items, you could get that. That will work in parallel and potentially hit up to 100 different partitions to retrieve that. If you're doing a query, which is where the question was associated, a query is associated with a hash range primary key. So a hash range gives you the one-to-many relationship where you have a single hash, for example, user ID, and then a range key which unifies the key into a primary key. But that could be, say, a timestamp. And so if you just ask a query, if you give the query just the hash credentials, then the full data set will come back in range sorted order. So is there any limitation? There's not a limitation, but obviously latency for returning 50 million records will be higher for the last record than it will be for the first record. But what you'll get is a very, very low latency experience. Most of that data is co-located physically, so the access will be extremely fast. It won't be across the network. And we just recommend you try it. If you're using local secondary indexes, that is, they operate within the construct of an item collection. where we do constrain each hash key to a 10 gig partition. That is so we can do all the operations locally. And the advantage of that is when you put items into the source table, you don't incur a latency overhead as you do with traditional databases. The downside is each hash key is limited to 10 gig, which, by the way, per hash key is a very high limit.
Mm-hmm. So we have one here on what is the best practice for periodic, large-scale, tens of millions, update or insert to a DynamoDB table. Specifically, this would be a data export from a Hive table in EMR. That's a good question. So EMR, if you're not familiar with it, is a managed Hadoop service, Elastic MapReduce. And we've actually embedded and integrated EMR with DynamoDB. So when you're working with Hive, which is an SQL-like query language which sits on top of MapReduce on Hadoop, Hive will actually allow you to create an external table, which is a DynamoDB table. You specify the keys and the values, and you can do SQL-style queries against the DynamoDB table using Hive. The nice thing is that because it's nicely integrated into Hive on EMR, you can actually set the level of provision throughput that query will consume. So if you have a production database that you're loading data into, you may not want your Hive query to completely overrun the provision throughput which your other clients are using. So you can set it to be very low. Alternatively, if you're just doing a data load, you can set it to be 100% of the provision throughput of your DynamoDB table. Then you just crank up the provision throughput of your DynamoDB table, and you can easily handle those tens of millions of inserts using an external table integration using EMR. And you can do the same thing for taking data from DynamoDB and moving it into an S3 bucket or querying across data in an S3 bucket and DynamoDB. So there's some very nice integration points inside EMR.
Great, thanks. So we've got time for a couple more. You mentioned 5 and 10 read-write capacity units in the free tier for DynamoDB. What does this capacity denote? So it's a good question. What we refer to when we say a read unit or a write unit is essentially a read per second or a write per second for a certain size, a maximum size of data. So for writes, that is 1K. For reads, it's 4K. So in general, it translates to reads per second or writes per second. But if you do have larger items, for example, 3K of items or just over 3K, you may have to consume 4K of write units and 1K of read unit to move that item. So a put of that item will maybe consume 4 write units. So in general, look at your items, your average item size first. If they're generally under 1K, then that translates to basically per second.
We have a question, are there any sample applications we can use as a guide? Absolutely. Take a look at your SDK of choice, and you'll find example code in there relating to DynamoDB. It's really, as I say, the API to DynamoDB is extremely simple. You can get up and running literally in 5 or 10 minutes after you created your first table. So there's example code in those. And as I say, we also have example iOS code available for our geospatial library as well. And
I'll chime in about mobile push. We actually have sample applications for iOS, Android, and Kindle Fire that help you get started sending your first push notification in just a few minutes. You can get through that through the SNS documentation.
Great. One more question, I think. What is the upgrade path from SimpleDB to DynamoDB? Firstly, there's no need to move if you don't want to move. We encourage you, if you need higher scale or lower cost, which is quite a common requirement these days, then that is something to look at. With local secondary indexes in DynamoDB, you get a very consistent mapping between the concept of a domain and a table in DynamoDB. With all the attributes indexed in SimpleDB, you can basically build a local secondary index on the same structure, the same table structure in DynamoDB and support up to 6 different or more, 5 additional read access patterns. So if you think you can access it by the hash key as well as the range key, with local secondary indexes, and this answers another question, can you have other range keys against the table? With local secondary indexes, what you're doing is providing an alternate range key. So again, with the same hash, you have a different lookup. So you may look up from timestamp in one case or user ID in another case, and so on. So yes, that mapping provides you with basically the support for multiple query patterns that you were familiar with from SimpleDB, as well as the power and the scalability of DynamoDB. So the process is fairly simple. Just unload the data in CSV or delimited format and load it back into DynamoDB. Tables in non-relational are fortunate in that they don't have the intra-database relations to worry about. No parent-child relationships are expressed in the database. So you can basically move data as a discrete set, move it out, move it in, and so on. Your application needs to, it manages all those relationships.
All right, one more, just because actually two more. So somebody asked, for a data import scenario, can I provision something like 10,000 writes and then set it to 10 once it's done? How does the pricing work? The answer is absolutely. So you pay for DynamoDB in two ways. You pay for the provision throughput, and you pay for what you provisioned, not what you've actually used. So you could set up your 10,000 writes, 10,000 write I/O, and then you'll pay for those as and when you're using them. And then when you scale back down to 10, you'll only pay for 10. So you pay for that, but you also pay for the storage under the hood as well. So those are the two key levers for pricing on DynamoDB. But absolutely, you can scale up to 10,000 and then scale it back down to 10 once it's done. The final question is, when is DynamoDB planned to be out of beta? This is an interesting question. So we've got nothing to announce today, but I did want to just touch on what we mean at AWS when we talk about beta or beta. We use it slightly differently to how maybe other customers or other companies use it. When we talk about beta, we're talking about a service which is operationally stable, which is designed for production use, and which, as you can see, customers are already using for very, very high scale. But beta for us means that it doesn't quite fulfill our original vision in terms of the feature set. So our goal is always to get our services operationally stable and get them out in front of customers as soon as possible, and then use the feedback from customers working with the service to improve and add features to that service over time. And when we eventually get to a point where it's kind of fulfilled our original vision for what you can consider 1.0, that's when we remove the beta tag. This has nothing to do with operational stability or suitability for production systems. It has everything to do with our vision for the feature set for DynamoDB. We released it with a minimal set deliberately, and then we've iterated and added features time and time again as more and more customers have come on board. So again, nothing to announce today, but that's our approach when it comes to beta.